In this video, we're going to use the definition of a logarithm to rewrite logarithms as exponential statements, and then we're going to rewrite exponential statements as logarithms, and at the very end of the video, we're going to evaluate some logarithms exactly. All right, so here I have 2 equals the log base 3 of x. I want to rewrite this as an exponential statement, so I remember that this really is a base, the exponent, and what it's equal to. The logarithm base 3 of x is 2 is saying 2 is the power we raise 3 to in order to get x. So there's my exponential statement. Now, I know that this is really telling us that x is 9, right? But I was instructed just to write it down as an exponential statement, so I'm going to leave it right like that. 3 squared is equal to x, as silly as I might feel. Here, the base is just called b. My logarithm is equal to 7. That becomes my exponent. And then finally, that's equal to 32. Next up, we have the log base 5 of 7 is equal to y. So 5 raised to the y power equals 7. Well, notice this equation was written down with the sides reversed, but that doesn't matter. The base gets raised to an exponent is equal to the argument of the logarithm. Just using that definition of logarithm from our previous video. Well, if we can convert logarithms to exponentials, we can convert exponentials to logarithms. So here I have 3 exponential statements, and I'm given the same instructions. Well, my exponent is equal to the logarithm of the base 5 of 25. Literally saying 2 is the exponent, we raise 5 to get 25. All right, here, my exponent is 3. The base is called b, and so 3 is the number we would raise the base b to in order to get 27. One more here. Y is equal to the log base e of 41. And I hope you've watched the videos that came along in my math lab, and we know that a log base e is also called the natural logarithm, and that's the way we really want to write that one down. Y is equal to the natural log of 41. Finally, we have 4 logarithms to evaluate exactly. We're not going to use a calculator for these. We can evaluate these ones exactly. And one thing we could actually do, if we needed to, we could say log base 3 of 81 is equal to some number y that I'm looking for. We could rewrite this in exponential form. Right? This says 3 to the y is equal to 81. And so now I'm thinking, 3 raised to what power is 81? Well, that's 3 to the 4th power. I'm really thinking that 81 is 9 times 9. 9 is 3 squared, so I have 4 3's to get to 81. Now, we could actually just look at this and say, what power do I raise 3 to get 81? And probably just say this is equal to 4. And that's my final answer, writing down that the logarithm itself is equal to 4, which I should probably actually write down separately and not borrow from where the question was written. So log base 3 of 81 is 4. There's the logarithm I was asked to evaluate equal to 4, and I was thinking about it as this exponential statement. So I want to do one more that way. So maybe this log base 4 of 1/64 is equal to some number y that I'm looking for. As an exponential, that would be 4 raised to the y power is equal to 1 over 64. I'm going to go on and write that as a 64 to the minus 1st. And I'm thinking to myself, well, do I know anything about 64? Like, what power of 4 is 64? Just ignoring the minus 1 for a moment. Well, 64 is 4 to the 3rd power. So multiplying that, apparently I'm looking for minus 3. 4 raised to the minus 3rd would be 1/64. So the log base 4 of 1/64 is minus 3. All right, this one I want to try to do without having to do any scratch work. What power do I raise 10 to in order to get 1,000? Well, talking to myself in my kitchen filming this, but I'm going to imagine that you just said 3. 10 times 10 times 10 is 1,000. And finally, on this last one, this one's almost silly. Every root we ever see is really an exponent. So I rewrote the same thing again. I'll just pretend I didn't write that equal. So this that I was given is equal to the log base 5 of 5 to the 1/4. All right, well, this one's actually really silly at this point. What power do I raise 5 to get 5 to the 1/4? Well, pretty sure that exponent has to be 1/4. And there we have some examples where we get to use the definition of the logarithm.